Thank you for the introduction and good afternoon, colleagues. Welcome to the second day of our two-day event, which is, of course, UNIDO's contribution to the commemoration of the second International Day of Clean Air for Blue Skies. Yesterday, we had the opportunity to listen to our colleagues' excellent presentation on the foundations of air pollution, its impact on human health and the economy even, and UNIDO's work on this area. Today, we are most privileged to have with us a esteemed expert, of course, Professor West, who will discuss how we could achieve global clean air through climate action. While traditional industrial development has largely contributed to improved living conditions and economic growth across the world, we also recognize that it has definitely taken its toll on both the environment and human health. The European Respiratory Review highlights that, quote, that both short and long-term exposure to air pollution may be important aggravating factors for the transmission, severity, and lethality of the COVID-19 virus, unquote. Within this particular context, UNIDO's mandate of promoting industrial development for poverty reduction, inclusive globalization, and environmental sustainability is more relevant than ever. UNIDO as an organization has long recognized the linkages between sustainable management of the global environment and protection of human health. Our work, of course, promotes the greening of the environment at the systemic level in industrial development, considering both economic development and environmental sustainability. We work directly on air pollution mitigation through technical cooperation projects, mainly on climate change, resource efficiency, circular economy, and of course, chemicals and waste management. The two-day activity puts this work into focus and reaffirm UNIDO's commitment to derive high in our agenda the provision of assistance to combat environmental issues. Once again, I would like to express my sincerest appreciation to all the participants for attending today's event, and particularly our sincere appreciation, of course, to the UNIDO Staff Union for their support. Thank you very much, and I wish everybody a productive event. Alfredo, please.
Thank you very much, Carmela. Dear colleagues, being a UNIDO focal point for this celebration is like being a master cook. And it has certain advantages. For instance, you can pick the juiciest piece or grab the cherry on top of the cake. I have truly enjoyed organizing this event with my colleagues and the staff union. For our colleagues, and now I declare that it is fair that I pick this, my favorite spot in today's agenda. Following Carmela's welcoming address, as UNIDO focal point for the International Day for Clean Airs and Blue Skies, it is my great honor and pleasure to introduce our keynote speaker. He's joining us from a wonderful location that truly enjoys the famous Carolina blue skies. There, he's a faculty member at the Gillings School of Global Public Health, one of the global top programs of public health, located at the first public university in the history of the United States of America. Colleagues, please join me to welcome Dr. Jason West, one of the world's pioneers and leading experts conducting interdisciplinary scientific and policy research that connects air pollution, climate change, energy, and human health. For this endeavor, he uses models of atmospheric transport and chemistry at global through local scales. As Professor of Environmental Sciences and Engineering at the University of North Carolina at Chapel Hill, Dr. West has served on the Scientific Steering Committee of the International Commission on Atmospheric Chemistry and Global Pollution, on the NASA Health and Air Quality Applied Science team and as a Leopold Leadership Fellow. Professor West is on the editorial board of Atmospheric Chemistry and Physics and of the reviews section of Environmental Research Letters. He has published more than 70 referred articles in prominent journals, including Nature, Climate Change, and Nature Geoscience. He has written and spoken with the public extensively on global health, change, and air pollution, and his work has been featured in major news outlets, including New York Times and CBS News. Professor West earned a Bachelor of Science degree from Duke University and a Master of Philosophy from the University of Cambridge, also a Master of Science and a PhD from Carnegie Mellon University. He has worked as a researcher at the MIT and Princeton, was an American Association for the Advancement of Science Fellow at the US Environmental Protection Agency, and a visiting scientist at the National Institute for Ecology in Mexico City. Thanking him on behalf of UNIDO for his generous contribution to deliver this lecture that enriches our celebration, and without further ado, the floor is yours, Professor West. Thank you.
Well, thank you for the opportunity to speak with you today, and thank you all for your interest in this topic. Of course, it's a very important topic, and we'll talk about that some more. Let me fix my screen. There we go. Over the past year, the COVID pandemic has really captured everybody's attention, I would say rightly so. But we also need to take a longer view and think about the impacts of what issues are pressing over the coming century. And I think climate change will is emerging now, and will become really one of the most important issues facing humanity over the next century. And so climate is a central theme here. I'll really focus, though, on looking at climate change through the lens of the problem that air pollution poses for health. And I'm going to make the case that air pollution has has really been a plague affecting human health over the past century. It's a 20th century plague that now continues into the 21st century. And that we can address it through 21st century actions that address climate change. And I'll discuss some of those linkages about how air pollution, health, and climate are linked to one another, as well as make the case that through climate action, we can make significant strides in improving air quality and improving health. So that's the game plan for today. And I'll talk for some 45 minutes or so and look forward to your questions. Let's start with the Industrial Revolution. This was in one of the industrial sites in England in the late 19th century. Certainly one of the founding regions for the Industrial Revolution. Certainly there's big smokestacks pumping out all kinds of smoke. They're burning coal here. What may be less obvious here is over in the corner here, what looks like homes and businesses in very close proximity to this huge source of air pollution. And that's what cities were like back then. Without motorized transport, people lived very close to where they worked. And so it's been the case through human history, certainly since the Industrial Revolution, that people have been exposed to extremely high levels of air pollution, at least in some places. The effect of the Industrial Revolution is illustrated here. Many people in the public don't know what this figure looks like, but we transitioned from a world that was biomass fueled by wood, to then in the Industrial Revolution, coal became available, and we then had more ability to transform energy into ways that were useful for us. Then came oil, which became used mainly as a transportation fuel later in the 20th century. Gas is a flexible fuel, so fossil gas can be used for power plants, also for heating homes. And here at the top, we have non-polluting from a carbon point of view sources of energy, and they're rapidly growing, but they're still a very small fraction of this whole thing. So the picture that we have is one of rapid transformation where we're accessing different forms of energy and using it to our advantage. And the benefits of that to society, I don't have to tell you, it's apparent all around us. But there are some detrimental effects of that as well through air pollution and through climate change. Let's take air pollution first, going through history. The worst air pollution episode in United States history happened in Donora, Pennsylvania, a fairly small town, an industrial town. This was the picture of episode that lasted 3 or 4 days. This was a daytime picture with the street lights on and nobody out on the streets. The air pollution was so severe. About a third of the town became sick, and 20 people died during this episode in what was not a very big town. 1952 in London, now this was a big city with a big population exposed to it, and there were measures of air pollution. So this is a measure of smoke here, and this is day by day. So the severe smoke lasted about a week. This is another daytime picture of buses with lights on. And this is a count of deaths day by day. And if you add up the deaths that happened above what you might say would be the normal level of deaths, about 4,000 people died during this 1 week long episode of severe smoke. And it's been argued that in fact the number should be much higher than that, people that have gone back and looked at it more carefully. So it's been apparent for some time now that very severe air pollution can cause people to die prematurely, which leaves us with questions of what about day-to-day air pollution that we breathe every day. If we go forward now into the 1950s, this is Los Angeles, where a new form of air pollution emerged. This is photochemical smog, where ozone is an important part of that air pollution mixture. The women here are rubbing their eyes and noses because ozone is an irritant that at high concentration will irritate your eyes and nose. And Los Angeles became a perfect storm for this new form of air pollution to emerge, because you need 3 things to generate ozone: sunlight, which is abundant in Los Angeles, nitrogen oxides, and volatile organic compounds. The NOx came from motor vehicles, which were now newly available and much more prevalent than before. The VOCs came from the motor vehicles and also heavy industry within Los Angeles. There was at this time oil refineries that were emitting a lot of VOCs into the air. The 3 mixed to form ozone air pollution, but we learned later that ozone is pervasive. Even though it's so high in Los Angeles, it exists all around the world. We first saw it, up and down the eastern states of the United States, and among we saw that ozone was transported among countries in Western Europe. Now we see that it's transported across continents as well. Going forward in time in the United States, we took action to address air pollution, and the 1970 Clean Air Act was the start of that, but the 1990 Clean Air Act amendments were really very important. This is showing several different air pollutants relative to their standard here and how they've changed through time. This blue line is SO2, which declined by 89% over this period. A really remarkable transformation as we've cleaned up, especially coal-fired power plants, by putting smokestack scrubbers on them, driving SO2 down. Other pollutants have decreased pretty substantially as well. This is a success story that we don't tell enough in the United States. It also happened in Western Europe, of course, over this period as well. Even though our air was getting cleaner, public awareness of air pollution as a problem was growing. So if you ask people about air pollution, they wouldn't have an idea, I think, that we've improved as much as we have. And this is another indication of that improvement, looking at satellite observations of NO2. It's just one pollutant, but it's a pollutant that we can see well from satellites. This is what it was in 2005, cleaned up really remarkably by 2018. Again, we've made big strides to improve our air. How about the rest of the world? This is Beijing in what became known as the Airpocalypse, January 14th, 2013. At the bottom here are clouds. This is air pollution that we're seeing here. These are the mountains to the north of Beijing. And you can see snow on the mountains and air pollution spilling out through the mountain passes very vividly. The air pollution was measured during this episode as being 20 times the World Health Organization guideline. Here are some pictures of what it looked like on the ground that day and during those few days. China seems to actually be turning the corner toward cleaner air, and I'll show you some figures that suggest that later. How about elsewhere in the world? This is the Ganges River Basin, India and Bangladesh here, Nepal up at the top, with one of the most densely populated regions of the world with severe air pollution. The Himalayan mountains keep some of the pollution trapped from escaping to the north. And so it builds up along the Ganges River here, exposing people to very high levels of air pollution. And the COVID lockdowns brought people's attention to how clean their air could be. And this, of course, is from New Delhi, but people in many places observed that they could see mountains that they didn't know existed so close to their cities for the first time, along with our Clean Air for Blue Skies theme. About 95% of the world's population lives in areas that exceed the WHO guideline for ambient PM 2.5. That's throughout the world. So air pollution continues to be a problem in the US and Europe, even though we've improved it quite a lot. It's really a problem for the world's population, for everybody, even though some places are more polluted than others. And when we think about what regions will emerge as being the most important for air pollution, China's turned the corner toward cleaner air. India continues to get worse. Africa will likely continue to get worse, as will places like the Middle East, Southeast Asia, and Latin America. So we really have a global problem here. And about 71% of the global population-weighted ambient PM 2.5 air pollution comes from fossil fuel combustion. In some places that wouldn't be the case. So you might have a desert city that gets a lot of particulate matter from desert dust. You might have not fossil fuels, but wood burning being very important in some cities or some regions. But by and large, when we look at the world's population, it's fossil fuel combustion that is the driving force for most of the PM air pollution that the world's population is exposed to. I wasn't sure how much you knew about PM, so I thought I'd show this figure. This is a human hair magnified. This is grains of beach sand. This is 10 microns, which in diameter, the blue ones, and then the little red spheres are 2.5 microns in diameter. These are invisible. And if we ask the question, and of course, PM 2.5 is a measure of particles this size and smaller. If we ask the question, how many particles are in a cubic centimeter of air? So a cubic centimeter is the tip of my little finger, right? The answer is about on the order of 1 million or so particles, even in a clean environment. So we're exposed to particles all the time. And one of the difficult things about particles, they range in size, but they also range in chemical composition, and they range in sources. So we could have particles, a single particle could be a mixture of stuff that was emitted from power plants, but also natural sources, and also motor vehicles. Aged air masses will mix particles so that it's hard to distinguish how much of that pollution comes from different sources. But nonetheless, we have methods to do that. So to get back to the health story, we saw that in cases like London, that severe air pollution could cause people to die. How about everyday air pollution? In the 1970s or so, we started getting what would be called daily time series studies showing that on days that are more polluted, more people die on those days, suggesting of wider effects. This was the first what would be called a long-term cohort study known as the Harvard Six City Study, published in 1993. So they're looking at the rate of dying. What they did here was they followed 8,000 adults that lived in 6 cities, and those 6 cities are denoted by these different letters. So Steubenville, Ohio was the most polluted, and then less polluted places here. They plotted here, and then they followed those people until they died over many years and noted at what age they died and what causes they died from. This is the risk of dying, and it's regressed here against fine particle concentration. So the most polluted city had the highest risk of dying. Also sulfate particles here. So it's probably the case that these fine particles, this is PM 2.5 that we know today, it's probably the case that most of that PM 2.5 was composed of sulfate in many of these places. These other measures of air pollution also show relationships, but not as strikingly strong a relationship as we see here. The New York Times reporting on this said that studies say that soot kills up to 60,000 a year in the United States. And from what we know today, that number is about right. Knowing that air pollution affects health, we'd like to understand what the effects of air pollution on health are globally. And so we asked the question, what is the global burden of ambient air pollution on human health? So there's part of this that is understanding the relationship between concentration and health that we can get from epidemiological studies like I just showed you. The other part of it, though, became a question of what are ground level concentrations all around the world. And we'd like to know that at fine spatial resolution, because you could have very polluted conditions in the city and then go outside the city into the countryside only a few tens of kilometers, and you can have pretty clean air, depending on where you are, of course. So we'd like to understand that at very fine resolution. This actually limited our ability to come up with an estimate of global air pollution effects on health for many years. And then about 2010, we had 2 breakthroughs. One is shown here. This is Aaron van Donkelaar. He published that we could use measures of aerosols from satellites to infer what ground level concentrations of air pollutants are. And so for the first time, we had a global data set for ambient air pollution. And the other breakthrough came from my lab, where we used computer models for the first time, computer models to represent what global air pollutant concentrations are to estimate burden on human health. Models are uncertain, but nonetheless, they give us complete spatial and time coverage, and that is an advantage of using models. So in this study, we used actually many different models, estimating 500,000 deaths from ozone, 2.1 million deaths or so from PM 2.5. And this was our estimate of where those deaths were occurred, with actually half of them we estimated in East Asia. But many deaths in many places all around the world. So no place is really immune to this effect of air pollution that cause people to die prematurely. The best estimates that we have today of the effect of air pollution on health come from what's known as the Global Burden of Disease Assessments. And this was their 2019 assessment. They had estimated from ambient PM 2.5 pollution, 4.1 million deaths, ambient ozone pollution, 400,000 or so deaths per year globally. And household air pollution from solid fuels, 2.3 million deaths. I'll talk about that for a minute. Alfredo had mentioned that I had worked in Mexico, and while there I had traveled in the rural regions of Mexico, interested in seeing how people lived and worked and what sources of energy they had. This is, I remember her name, Regina Banda, who had made lunch for me over this, and this was her cooking environment. And you can see that the walls of her adobe home are completely coated with black soot. There was no ventilation in this room at all, except for the door that we walked through to enter it. She spends many hours a day in this enclosed environment, and many children spend a lot of time as well in environments like this, exposed to extremely high levels of air pollution. I should say that she's cooking over a wood fire, and she's done this for years. She was extremely skillful at doing that. I would have had a very hard time cooking in that situation, but she did it very well. So that is where this 2.3 million deaths comes from. It's not a problem in the United States and Europe. It is a problem in Africa, throughout Asia, Latin America. Right. So if we add these up, that's 6.7 million deaths. That's one of every 8.5 deaths that happen globally, a striking number. One of the nice things about the Global Burden of Disease Assessment is that they've estimated a health burden associated with many different risk factors for health, such that then you could compare them one another, and this is the ranking of the highest risk factors. So here is high blood pressure, tobacco use, dietary risks. Air pollution comes in at number 4. And we didn't know this before 2010 or so, that air pollution is actually the environmentally most important risk factor for global health. And look at the things around it. These are things that are widely appreciated for being important for health. And here is ambient air pollution coming in at number 4. I made the case that air pollution was a 20th century plague, but nobody has actually estimated the number of people that died over the whole 20th century. We just know that places were very polluted. But the Global Burden of Disease Assessment does estimate from over the period 1990 to 2019, and when you add that up, it's an estimate of 98 million deaths per year over that period. So a pretty strikingly large number. To put that into context, this is a comparison that I like to do. This number of 6.7 million deaths from air pollution, that's one of every 8.5 deaths. I've listed a bunch of other causes of deaths here, and if I were to ask you which of the, how air pollution compares with this list of causes of death, you might be surprised if I told you that air pollution was number 1 on this list. Let's look at the numbers. Air pollution is actually about as important for causes of death globally as the sum of all of these 7 causes of death. And that takes a lot of people by surprise. One of the things about air pollution, though, is it's a risk factor. It's causing people to die prematurely from lung cancer, from stroke, from heart attacks. And so it's not air pollution that's listed as the cause of death on their death certificate. And so that becomes a barrier in communicating the importance of air pollution, in that we know who dies of breast cancer and HIV because it says so on their death certificates. But for air pollution, that's not the case. So we cannot identify clearly who are the people that died because of air pollution. Rather, it's a risk factor that causes many people to die of air pollution, and we can quantify what that number is with a pretty good degree of certainty. Okay. Before I leave the Global Burden of Disease Assessment, I want to mention one other way that my lab contributed to that, which is that we produced the maps of global ozone concentration that were used by GBD to estimate the 400,000 or so deaths per year that were done. And we did this through a statistical data fusion of combining observations of ozone. And there was a comment before we started talking here about where monitors exist. This is for ozone, showing where those exist, with huge gaps in South Africa, South America, Africa, Southeast Asia, with more presence of monitors in Japan and Korea, and now China. We did a data fusion of these monitors with several different global atmospheric models, estimating what global air pollutant concentrations are. We did that again for GBD 2019, where now we're estimating ozone each year over this entire period, we're using new observations, including new observations from China and more computer models. We do a smooth weighting of observations over space and time using what's known as the Bayesian maximum entropy method. And we've produced then this data set that covers the whole world yearly. And we're hoping that this data set will be used for a variety of different applications in addition to its use for GBD. Just to show you some of the results of our work, this is just for ozone, you could say the second most important global air for health. This is looking year by year at exposure of the global population to ozone, showing that ozone is going up by and large. So we have more exposure here in these blue colors and less in the red colors as we step forward through time. And this is showing trends all around the world in different world regions. This is the global population weighted ozone going up through time. India is, for ozone, the most likely the most polluted region of the world. That's driving this global trend up. East Asia as well. There's some regions that have improved their air pollution. So North America has come down, also Russia has, but it's the rise of ozone air pollution in places like South and East Asia, as well as Africa, that's driving this global trend toward higher ozone. Okay, so I'll change theme a little bit. I'm a computer modeler, and one of the interesting things for me in using computer models is playing what-if games so that we can control air pollutants and see what effects it has. And we've used this for a lot of different applications. Here we were studying the effects of one continent's air pollution on air pollution related deaths in other continents. And we showed for the first time that ozone that comes from North American and European emissions might cause more deaths outside of those regions than within. And that was a little surprising to us at first, but the logic makes sense that even if places downwind like India and China are exposed to much less ozone air pollution than Europe itself is from European emissions, there's a much larger population exposed to that smaller change in concentration that's attributable to European air pollution. And that's responsible for this effect that we see. We also looked at then using our computer model to separate out the effects of different emission sources on air pollution related deaths. So, and in different places we get different answers. So what's plotted here are the fraction of total PM2.5 related deaths that are associated with energy, industry, et cetera. So we see that energy, including power plants, transportation, are very important sources of PM2.5 related deaths in North America and Europe. Residential and commercial emissions are very important in places like India, and industry is very important in China. So you get a bit of a different answer depending on where you are in the world. Okay, I'll change theme again and then come back to some more work that my lab has done, but I want to talk about climate change a little bit, and I know you got a primer on climate change yesterday. I'll do that through the lens of talking about the new IPCC report. And some of the language in that report is very important here. So the new IPCC report said, it is unequivocal that human influence has warmed the atmosphere, ocean, and land. It says elsewhere in that report that this is established science, that humans are causing the climate changes that we see today. And this is a much stronger language than the climate change reports of the past couple decades. And that stronger language reflects greater confidence among the world scientists, including myself, that we have an influence on the world's climate system. How much of that climate change is caused by human activities? We've observed that there is a 1.1 degrees Celsius rise in temperature over the last decade versus a century ago. And that is the black line here. When we use computer models and simulate the effects of human activities and natural influences, versus if we only use natural influences in those computer models, that's changes in solar output, the output of the sun, and changes in volcanic activity. We have no way of explaining this sustained rise of temperatures since 1970 or so to today. And so it's actually likely that all of the observed temperature change is due to human activities. You might be interested as well in severe storms, and the IPCC, these are their words, concluded that human-induced climate change is already affecting many weather and climate extremes in every region across the globe. And those extremes include heat waves, heavy precipitation, droughts, and tropical cyclones. These are pictures from just the last 2 weeks from my country, so Louisiana, California, New York. You all are probably more aware than I am of severe weather disasters and their impacts in the nations that you try to assist, like UNIDO. When we look to the future, also this is from the IPCC, we learned that the extent of future warming is within our control. So we have here a range of different scenarios and what they mean for temperature change. This is historic temperature change. We've already gone up by 1 degree Celsius. And under these different scenarios, ranging from a rapid growth scenario, we could be talking about temperature changes that are on the order of 4 to 5 degrees Celsius. That would be comparable to the temperature changes that we've seen globally from the last ice age to the present. So on a global scale, really rapid change over the course of a century and really striking change. Even under these scenarios where climate change stabilizes, at the bottom here, the blue scenarios, they don't make climate change go away. So we continue to experience climate change for some decades to come, but it keeps us from going on the path of runaway climate change seen here. What do emissions have to look like to yield these temperature changes on the left? And that's shown on the right here. So under the red scenario, we triple global emissions of greenhouse gases over the course of the next century by 2100. Versus under the blue scenarios, we actually drive emissions to near zero in the latter half of this century. Certainly, it's going to take a lot of work to do that. And it leaves us with the question, how do we support a growing global population, an expanding economy, getting people the things that we want them to have, connectivity through the internet, mobility, ability to travel from place to place, better standards of living, large screen TVs. Those are the things that we all want, right? And so how do we achieve in getting those things while we're driving emissions down to zero? So one of the important questions for us going forward. The other point that I make here is that global warming will only stop after emissions go to near zero. So under this scenario here, where temperature change is rising, it will continue to keep rising as long as emissions stay at something greater than zero. Only by turning it back to zero will we eventually stop climate change. So we could do that in the shorter term and avoid climate change, but we could also wait for some climate change to happen along with the many different effects associated with it before we finally get our act together and stop climate change. Okay, so I said I would talk about how these problems of air pollution and climate change are related to one another. And there are several ways here, and I'll just present those here and then talk about some of these in greater detail. So the first here is that several air pollutants affect climate. So ozone is an air pollutant. It's also a greenhouse gas. And aerosols in the air pollution world would be called particulate matter, or PM 2.5. They, by and large, scatter and absorb sunlight and affect clouds. This is generally a cooling influence on the Earth's climate. Secondly, changes in climate may affect air quality. So climate change affects meteorology. It also affects the air's temperature, which affects the reaction rates of the reactions that form pollutants like ozone. It also affects natural emissions from trees. So trees naturally put out pollutants, but the amount that trees will emit will increase as climate changes. And so we expect that by and large, climate change will make air pollution worse. I'll make the case later that this is probably a minor influence, but not negligible. The really important influence here is number 3 here, that the sources of air pollutants and greenhouse gases are shared, and those are in fossil fuel combustion. So by taking action to address one type of pollutant, either air pollutants or greenhouse gases, we could be having an effect, we likely will be having an effect on the other kind of pollutant. And that, it turns out, I think, is the most important of these influences. But the other influence here is that climate change may influence demands for energy and therefore emissions. So we expect by and large that demands for home heating or building heating will go down, but demands for building cooling will go up. And so needs for air conditioning will go up through time. Okay, I'll talk about number 1, 2, and 3 here in a little bit more detail, showing some work from my lab. So this is looking at short-lived climate forcers. So this is showing the warming influence in degrees Celsius from the IPCC report. So this is the warming influence of carbon dioxide. Methane's been historically very important here. And then here is cooling that comes about from different forms of particles, with sulfur dioxide emissions being the most important for those particles. If we look at what are short-lived climate pollutants, it's methane, the halogenated gases which are used as refrigerants, and the refrigerants that are used in refrigerators, as well as air conditioning systems. They eventually leak out and are very potent greenhouse gases. Volatile organic compounds and carbon monoxide contribute to ozone air pollution, so that's an influence here. And then, of course, black carbon as well. We have an opportunity through these types of short-lived climate forcers, if we reduce their emissions, to reduce the reductions decrease the short-term rate of warming because they're short-lived, and they improved air quality at the same time. So this is a win-win and a real opportunity to address 2 problems with the same action. And unfortunately, global methane concentrations and emissions keep going up. And so for methane, that's the biggest one of these. We're going in the wrong direction. Again, showing some work from my lab. I showed several years ago that methane emissions are a greenhouse gas, but they also react in the world's background to create ozone air pollution. And so we've shown through this study, we were interested in seeing, does it make sense from a cost-benefit point of view to control methane emissions because of the ozone air pollution and the health benefits that would result from it? And we showed that actually it would make sense. So we simulated here a 20% reduction of all human-caused methane emissions around the world, and showed that that would avoid 30,000 deaths or so by 2030. When we compared costs and benefits, the benefits of this action outweighed the costs of reducing 20% of global methane emissions, apart from obviously other benefits that you'd get from slowing down climate change. So the second linkage I mentioned was the effect of the effect of climate change to influence air quality. Here we looked at that using several different computer models that did simulations of climate change, future climate change in 2030, here in 2100. These are the results when we look at individual models, with some models saying that by and large, climate change would make air pollution less severe, but most models said it would make it more severe. When we look at for PM 2.5 here, the numbers are pretty big. So this is a couple 100,000 deaths per year in 2100 that would be attributable to climate change and its influence on PM 2.5. Where are those deaths globally? They're globally distributed here. And in fact, we found that climate change would make air pollution related deaths more severe in all continents except Africa is actually what we found. Okay. The third influence, though, is the one that I really want to talk about because I think it's the most important, which was the influence that air pollutants and greenhouse gases share common sources, and those are in fossil fuel combustion. So if we have here sources of pollutants, these are sources of both air pollutants and greenhouse gases. And if we take some action to control emissions from those sources, we're very likely to have an effect on the other type of air pollutant. So looking at it from a greenhouse gas control point of view, if we reduce greenhouse gases, we're slowing down climate change, but we're also reducing emissions of air pollutants from those same sources. And that has an air pollution benefit with a health benefit to come out at the end of the day. So this influence, one of the appealing things about reducing greenhouse gases is that the reductions in air pollutants that result happen immediately and locally. Whereas for greenhouse gases, the influence that we see for the climate system, we might be reluctant to take action to address climate change because those benefits are shared with other countries and are distributed for many years far into the future. In fact, we see a local and immediate benefit that comes about from reductions in air pollutants from those same sources. So my lab used our computer models to analyze this, and this is what we found. So this is global air pollution related deaths changes in global air pollution related deaths in the blue scenario under a reference case scenario, and under the red scenario where the world is taking action to reduce greenhouse gas emissions. So we've succeeded then in slowing down substantially climate change, not making climate change go away entirely, but it's the difference between the blue and the green, blue and the red here for PM 2.5 or for ozone that is the co-benefit. So the co-benefit that we estimated for PM 2.5 was in the near term, 500,000 or so deaths avoided by the global greenhouse gas control policy. And by 2100, 2 million or so deaths per year avoided by the greenhouse gas control policy. So pretty substantial benefits. We then compared the benefit that we see for health with the cost of taking action in the first place. And we looked at this for different world regions and as a global average. So in 2030 here, the red uses a high value of a life, the blue uses a low value of a life. And so these values are higher than other published studies had shown. But what I want you to take away from this is that here in green is an estimate of the costs of reducing greenhouse gases. So this is the marginal cost. In 2030 is very low because we have some low-hanging fruit, some easy ways to reduce air pollution, reduce greenhouse gas emissions cost effectively. Then as we go forward in time, we're moving up the cost curve, adopting more costly measures to reduce greenhouse gases. The spread here is the uncertainty in the cost. So by 2100, we don't know very well what those costs would be, but still here in 2030, for many world regions, the benefits outweigh the costs just for air pollution related deaths, not accounting for other benefits that you get from slowing down climate change. By 2050, that's still the case. By 2100, the costs, you could say, are comparable to the benefits, or the benefits are comparable to the costs. I'll skip this in the interest of time. Okay, so to close out my talk, I want to come back to this main theme. How can we address air pollution and climate change simultaneously? I've shown you that by taking action to control greenhouse gases, we can have pretty substantial benefits for air pollution and air pollution related health globally, as well as locally. But actually what we've seen historically over the past several decades has been a different story. This is from the United States again. So over this period, our economy has grown, people are driving more, we have a greater population that's using more energy. CO2 emissions have gone up over this period. Actually, the United States peaked in 2007, and it's come down a little bit since then. And over this period, as I said before, we've cleaned up our air quite a lot. So we've done this in a way that hasn't reduced CO2, but has improved air quality. And this has been mainly through smokestack emission controls on power plants and large industries, as well as motor vehicle emission controls. Those have been the two biggest effects. We've taken the pollutants out of the smokestack, basically, for both motor vehicles and power plants and large industries, with really substantial benefits for health, but not a benefit for CO2. This has been the case elsewhere as well. If we look at Europe, that's the case. And this is just the past less than a decade in China, where GDP is growing, coal use, population is growing, coal use has increased over this period, then thankfully flattened out. CO2 has flattened out from China. But here are emissions of pollutants, air pollutants, that have come down really substantially in a way that did not drive down CO2, again, through smokestack emission controls on power plants and large industries in China. Motor vehicles are less of an important source in China, but a growing source, but those are being controlled as well. My lab did a study as well. This is again focused on the United States, where we used an energy economics model and asked the question, how could we improve air quality most cost effectively? And we found that there were ways to do it really very cost effectively, including decreased use of industrial coal, building biomass. So burning wood in homes is a very polluting source of pollution that it's very easy to find other energy resources that could replace that would be much cleaner. And then industrial liquids, that would be liquid fuels. In doing this, we've reduced PM 2.5 emissions, SO2 emissions, NOx emissions really substantially, with benefits to human health that come about from it. But these actions do not control CO2 emissions. So this is telling us that even going forward, some of the actions that we would take to clean up air will not cause CO2. So I'm painting a picture that is maybe sounds contradictory. Cleaning up CO2 will reduce air pollutants from those same sources, but the actions that we've taken historically to reduce air pollution will not clean up CO2. That picture is changing though, and it's changing rapidly. And the reason why it's changing rapidly is where I'll end this discussion. So these are the costs of electricity generation in the United States over the past decade or so. This comes from Lazard, which is a consulting firm that looks at the costs of different energy resources. The big picture here, right? This is gas as a peaker plant. This is natural gas as baseload plant. This is coal. Costs haven't changed. Nuclear, if anything, the costs have gone up. This is utility scale solar panels, and this is wind. So the costs of wind and solar panels have decreased really substantially. For solar panels, this is a decrease of 90%. We're at 10% of the costs of utility scale solar that we were a decade ago. And this is changing the energy picture. Utilities are now choosing to use wind and solar increasingly, at least in the United States. It depends on where you are. These costs will vary from place to place, of course. But by and large, the costs are cheaper than building new fossil fueled power plants. And that's changing this energy picture. And it's changing it in such a way that we can envision going into the future solutions that will favor renewables over very polluting sources of energy. The other things that we need to enable this then, of course, are energy storage, and that's becoming cheaper as well. Because wind and solar are periodic and variable energy resources. And so we need to have a way to store energy at a utility scale. And that's becoming cheaper, such that through batteries, we could imagine that happening, as well as enabling those batteries, enabling electric vehicles as well. This is where I'll conclude, but I'll go over some of the big points that I've made. So air pollution, I've said, has been a 20th century plague that continues today. It will continue through the 21st century. Places like India and Africa and Southeast Asia will continue likely to get more polluted than before they finally turn the corner and start to clean up. And of course, how quickly that transition happens is within our control. It is a 20th century plague with a 20th century solution, 21st century solution being going to renewable energy and addressing climate change and air pollution all at the same time. Taking action to reduce greenhouse gas emissions will bring substantial benefits to air quality and health. And I showed that those benefits can exceed the cost of taking actions. Historically, his smokestack controls have addressed air pollution with little effects on CO2. But now that picture is changing, and it's changing again because of the falling cost of renewable energy, which makes climate mitigation more feasible with substantial benefits for air pollution and health. So I'll stop there. I have many people to thank, many students and collaborators that I've had the good fortune of working with over many years, as well as funding from the EPA, NASA, NIH, and the United States, among other funding sources. So thanks again for your attention, and I'll look forward to your questions.
Thank you very much, Professor West. This is a very informative presentation. I know that we have the time limitation and also would like to tackle as much as important topics, air pollution, climate change, but I found it very informative. And I hope that it speaks also to all our colleagues. We don't need to be an expert to have an opinion and also take action, because actually action will not come only from the experts, it will come from everybody. But thank you very much for giving us the science of air pollution, at least some aspects of it for today. We need also to bring in the engineering, the finance, and the politics. And because action has to be taken by member states, countries, in their policies, etc. But I really thank you very much for this presentation. And before going to the question and answer session, I would like to give the floor to my colleague, Kara. She will make an announcement. Kara?
Hi, yes, just to update everybody, I mentioned earlier the hashtags for the social media campaign, which I popped in the chat, the hashtag World Clean Air Day and hashtag Healthy Planet. We've officially supported the campaign from the UNIDO corporate accounts, and I will post those links in the chat now too. And we've also produced an article on UNIDO's work on air pollution and climate change, which goes through several of the key areas that we work in across the Environment and Energy Directorate, and I'll post that link in the chat for you to have a look at too. So thank you very much. And now we've received many positive comments in the chat already. So yes, thanks again, Professor West, for the presentation. But I think we can move to the Q&A. Thank you.
Professor West, I think you have also access to the Q&A part.
Oh, that's right, yes.
So no need to read it for you. You can have a look, and I think the first question is about...
Were there substantial reductions of greenhouse gas during the past 2 years with the pandemic, and does it have an impact to climate change? This is really an interesting case study. So people have really studied this pretty substantially. They found that globally, people were locked down, people were not traveling very much, working from home. The energy use changed quite a lot, and there was a substantial reduction for a few months. But even when we look at 2020 greenhouse gas emissions or estimates thereof, we think that global greenhouse gas emissions only decreased by about 10% or so, and are likely to, as the world resumes activities, and has in part resumed activities, have climbed up again and gone back to right where we were. There's sort of a hope in some places that Some of the, maybe working from home will be in part a solution that might stick with us, but many of the changes were really transient. And that change in greenhouse gas emissions, if you look at concentrations in the atmosphere, remember CO2 is long lived. Its lifetime in the atmosphere is a century. And that's something that I think the public has a hard time getting their heads around and quite appreciating. But if you look at greenhouse gas concentration, it doesn't show any influence at all of this 10% decrease. I mean, there is an influence, but it continues to rise. Air pollutants also went down, but that was also a temporary decrease. So we could ask the question, if staying at home and not doing anything is not the solution to climate change, what is? And I think we see that the answer is many people are limited in what their capability to do to address problems are. I can control my own activity. I can control what products I buy if I have information about what the greenhouse gas footprint of those products are. But in many countries, I have very little control over what source of electricity is powering my house. I have very little control over the fact that in many places in the United States, many places in the world, I have to use a personal vehicle to travel, and there aren't other very viable solutions. So it's those more systemic changes that are really the changes that we need to address climate change. That takes it out of a personal responsibility framing. So the solution to climate change to me is not, let's shame people into consuming less. That's certainly in the United States not a very politically viable strategy to begin with, but I would say it's also not a very effective strategy at controlling emissions. It's really a strategy of big government decisions, encouraging companies to make the right choices to change the energy resources that we use and how we use them. That's the solution to climate change. I can, if anybody wants to follow up on that, that would be great. I can see if there's other questions as well. So I'm looking at the chat. If anybody wants to, one of the organizers finds a good question and wants to unmute and ask it, please do.
I think there is a first question on the UN.
Right.
Yes, I think the short answer, yes, there are several UN organizations as usual that are working on the topic. It depends on the angle or the link you are making with air pollution to health, and then you will find the World Health Organization. We have also UN Environment, UNEP, United Nations Environment Program, working on air pollution. But what is now coming as a coordination mechanism, there is this United Nations Environmental Management Group. They are trying to coordinate action on air pollution or in chemicals and waste in general. And there is now a process similar to the one that was put in place for biodiversity that they are trying to do on air pollution, or pollution in general, actually, not only air pollution, but pollution in general. And this process will have a meeting in October 7th among the UN organizations, and UNIDO will participate to that process. And our DG will contribute to that process and see how we can come up with a joint work plan among UN agencies and how we can complement each other and avoid duplication of efforts. I don't see other questions, but if colleagues would like to.
We have one here from Carmela. What is your view on the transboundary nature of air pollution in terms of policy recommendations?
Yeah, so that's a good question. Air pollution, our concept of air pollution has changed through time. I mentioned the case of Los Angeles. Certainly it's a very polluted city, and you can drive out of the valley of Los Angeles and into the desert and you would find clean air pretty quickly. But that's and that's kind of where our thinking, one place certainly where our thinking about air pollution emerged. Going forward through time, then we saw that air pollution was being blown from state to state in the eastern United States, blown from country to country in Western Europe. So when we were thinking about acid rain, it was Sweden pointing its fingers at Belgium and Germany and the UK, and rightly so, because those were the sources of the acid rain problems that Sweden and Norway were seeing. So that changed our concept of air pollution as a global phenomenon. Now we have satellites that can follow dust plumes that blow off of the Sahara or the Gobi Desert, and we've had severe wildfires, and we can follow those dust plumes using satellites, in some cases around the world and back around again. Pretty remarkable that that we can observe that. It's changed how we think about air pollution. Certainly, air pollution is primarily a local phenomenon. If you have a polluted city and you're the environment minister for your city, you're going to look at local sources first. But through time, many cities have cleaned up their local sources, leaving then the states or provinces around them, upwind countries, as being very important. And those need to be addressed too, often through intergovernmental agreements of some sort. We've also now seen that, I use the case of methane. That is a very unique case, that methane actually contributes to the global background of ozone. Reducing methane emissions anywhere actually brings down ozone for everybody. Not by very much from one single action, but it improves everybody's air quality all at once. So this is a different case, and we need international bodies to address that. And so a role for UN types of bodies. There's been regional agreements. The most successful was the Convention on UNECE Convention on Long-Range Transport of Air Pollution, known as the Lertap Convention, which was historically the mechanism by which Western European countries agreed to reduce air pollution. But now its membership has grown, and it's including more countries in Central Asia as part of that. There's regional agreements in Latin America among countries, in South Asia, in East Asia among countries, where we're starting with cooperation among scientists just to share information, so we have a good information basis for understanding the air pollution problems. But that can hopefully then lead to, that shared understanding of the problem hopefully can lead to cooperative solutions. But again, I think, addressing more aggressively climate change will in part relieve air pollution problems pretty substantially. And so, aggressiveness there can go a long way toward solving these transboundary air pollution problems as well. Can you explain more about air pollution caused by residential and commercial sources? What are they and how can they be reduced? Why do they concentrate so much in Southeast Asia, right? So among residential and commercial sources, of course, every place is different, but when we look at low and middle income countries, it's the poorer segment of the population that's burning wood, or in some cases charcoal, that is a very substantial source of air pollution. Certainly in the countryside, but also actually in many cities. So I remember, many of you have probably traveled to many of these countries more than I have, but I remember being in Beijing years ago and seeing, it was in the wintertime, and there was carts of that were delivering coal briquettes to individual homes. I think that source of air pollution is reduced quite a lot in the center city in Beijing, but this is a widespread practice still throughout China of burning coal in homes, as it is for wood. The wood combustion is also a drain on the forest ecosystems, and so depleting the forest ecosystems with impacts on wildlife as well as products that people can extract from forests. Charcoal is widely used and created in rural areas and then transported into urban areas as a source of fuel. We have a project now that's studying Africa. My part in the project is doing computer modeling of air pollution there. But my colleagues there are really interested in, they're real experts in this area of cook stoves for rural Africa. And, some of the conclusions that they're reaching are, there's a lot of hope that improved efficiency cook stoves that are burning wood would be a good solution. And we just don't find that they bring very substantial carbon benefits or air pollution benefits. It's certainly better than the traditional ways of burning wood. But looking forward, I think we need to be thinking large scale over the course of a century of electrifying rural areas. That's certainly a big task, but one that would alleviate air pollution quite a lot. As well as, maybe some solutions like bottled LPG, liquefied petroleum gas, that is used widespread in some countries like Mexico that could be used elsewhere. So that was a great question. Hopefully my response helped. From a technical cooperation perspective, what measures are important to provide LDCs in developing countries in Africa, Asia, South America, et cetera, to avoid the pitfalls of air pollution, then control cycle, right? I think we've learned a lot in the United States and Europe that can be useful for poorer countries of the world. I mean, monetarily poor countries, not in other ways. I don't want to offend anybody. Low and middle income countries. So that is having to do with management of air pollution. It involves a government infrastructure that can quantify emissions from different sources, that can understand air pollution from a scientific perspective. Every city's at least a little bit different, right? And it's in the importance of different sources for air pollution there. As well as then government capability to put on regulations and enforce those regulations. Some of that government capacity is lacking, I think, in low and middle income countries. So that's, China would be an exception to that, where they have very strong government capacity. When the government says we're going to embark on a 5-year plan to clean up air pollution, it happens, right? But many countries, India is not like that, right? India has challenges legally in enforcing air pollution regulations. So those are some of the problems, but as well, I think emerging out of my presentation perhaps was another way to avoid pitfalls. You've probably heard people talk about leapfrogging technologies, and instead of putting up wires all over the country to have telephone service, now you're leapfrogging and jumping to cellular service and skipping the whole wire the whole country phase. And similarly, we could skip the whole dirty air pollution phase potentially if we can show that renewables are going to be cost effective and viable in these places. And the costs are coming down remarkably because the Chinese, more than anybody, have innovated and brought down those costs of production of solar panels. So the possibilities are there, and I'm hopeful that that will be adopted and increasingly used. So we could both envision, a centralized grid infrastructure, so a gridded infrastructure where we're electrifying poor parts of the world, but where we have very remote villages, we could also imagine microgrid systems that stand alone that would electrify a village using renewable energy. Those are hopeful directions forward.
Great. We also have a question, which I think is a fantastic one. As individuals, what can we do to reduce air pollution?
As individuals, yeah. I think there are many things we can do by looking at the products we buy and where we're getting our energy from. And, you know, but I'll make the case that, and certainly we should all do those things. I have solar panels on my home. I do that proudly, but I also don't think that asking people to put solar panels on their home is going to be a viable solution that's going to get us out of the climate problem or the air pollution problem. In the United States, we've addressed air pollution historically, but it hasn't come about by people driving less. It hasn't come about by people carpooling. It hasn't come about by you know, people wanting to buy the latest and greatest emission controls on their vehicles. It's been through government, and it hasn't come about by people using electricity, less electricity. It's come about by the government mandating that those pollution sources would be controlled. And we have a pretty substantial success story to tell for it. So I think it's through collective action on the sources of pollution that individuals have little control over that we're going to make really important strides forward. I made that case for climate change, but I think it's also true for air pollution. There's a question, why is indoor air quality important? Is indoor air quality a good investment? For example, different HVAC or air conditioning strategies, right? So indoor air quality is important. Most of us in the more wealthy countries of the world spend a great majority of our time indoors. So you know, we're exposed to indoor air. And we think that actually a lot of the signal that we see of, you know, when we do these epidemiological studies saying what is the influence of outdoor ambient air pollution on human health, we think that we're actually seeing people breathing indoor air that is a little bit more polluted because the outdoor air was more polluted. We can't measure everybody's indoor air to do a big study like that to understand what health effects are. But we expect that indoor air pollution is really important. Actually, the COVID situation and the whole COVID is airborne movement has really brought this to the forefront that indoor air quality is really important. So as I'm breathing out here in my office, I've taken my mask off, but I've opened the window to keep myself safe and to keep other people in the building safe. So that's really important. So that's when we talk about indoor air quality in an industrialized world perspective, it's building materials that are important, paints that are important. So my couch is off-gassing formaldehyde very slowly, but it does, and that's an air pollution concern. When we go to the low and middle income countries, it's this use of fuels, combusting fuels in an indoor environment that becomes extremely important. And that's an entirely different ballgame where, you know, in, I didn't say it, but in my home, one of the biggest sources of air pollution would be cooking. If I'm cooking over a gas stove, we have an electric induction stove, which is wonderful and has all the benefits of a gas stove. But you know, as you're cooking, actually particles are being released that you can breathe in, and that can be an important source of indoor air pollution. When you're talking about, again, low and middle income countries, it's an entirely different ballgame, much higher air pollutant concentrations. And that's from indoor combustion of fuels, burning stuff indoors. And it's that burning stuff that needs to be either moved to an outdoor environment. So in my world, many of my colleagues studying water and sanitation, and you've, I'm sure, run across those issues as well. And so for many years, the mantra was, we need clean water and sanitation. In our world of air pollution, we need clean fuels and ventilation. ventilate homes, so provide windows, ways that this very polluted environment can be, that the pollutant concentrations indoors can be reduced through ventilation. And we need clean fuels, and that can come about from possibly, as I said before, burning wood, but in a more efficient and controlled combustion environment. But ultimately, the better solutions are going to be using better fuels like LPG that don't produce as much smoke, and using possibly electrification of homes as well. Can we say that there is a direct correlation between poverty and air pollution? I believe that we can, not only among countries of the world, where poorer countries of the world, people that live in poverty are exposed to higher air pollution. It's because of the energy resources that they have available to them, as well as issues like the construction of their homes, not allowing ventilation, very small rooms where you might be cooking, for example. Those are important connections, but we can also make those connections between poverty and air pollution within even the United States or within Western Europe or Japan, that in many cases it's the poorer people that are living closer to big sources of air pollution. There it's not so much a domestic source of air pollution question, but rather where are people living with respect to big sources of air pollution around them. The poorest people live closer to, in the United States, live closer to freeways, so exposed to motor vehicles, lives closer to industrial sources of air pollution, live closer to big ports that have diesel sources of air pollution, live closer to airports, right, where they're not only exposed to air pollution, but noise pollution as well. So yes, I think there are very substantial connections between poverty and air pollution. And it's not only poverty, but in the United States, race as well. And I think that you can make that case as well internationally, that there are relationships between racial groups and exposure to air pollution as well.
I think one of the participants is requesting the floor. Carlos Hernandez, are you able to type the question or comment in the chat, please?
Oh, sorry, I probably was a mistake.
No problem. I can see we have one more question now.
Yeah, so I see the question, 6.67 million global deaths from air pollution. Can you say more about the specific disease? Is it asthma? The answer is we're not really able to pinpoint very specifically what the causes of increased cause of death is, but we can draw big categories. So by and large, it's heart attack, it's stroke, lung cancer, and then chronic respiratory diseases, which would include chronic obstructive pulmonary disease, also known as COPD. Asthma would be included in that. Certainly asthma is affected by ambient air pollution. And so we see strong relationships between people going to the emergency room with asthma attacks and air pollutant concentrations. But the number of asthma-related deaths is relatively low compared to these other things. So if we ask, what's the biggest cause of death in the United States, or what's the biggest cause of death globally? It's heart attack. And because air pollution affects heart attack, then now we're talking about big numbers of death. And that's why these numbers of death are pretty big. But there's also something to be learned from that as well. It's not just respiratory causes of death. So I mentioned lung cancer, you mentioned asthma, and I mentioned as well COPD. Those are influenced. But it's things that have to do with the whole cardiovascular system. So it's really suggesting that air pollution is being transported through the body. So very small particles can enter the bloodstream and transport particles throughout the body. People who have studied very carefully bodies of people after they have died, so medical doctors have done autopsies, you could say, where they've looked very carefully at people's brains and found very small particles that are stuck there within people's brains that got there because people had breathed them in and it entered the bloodstream. So it's not just your lung system, it's your whole cardiovascular system. It's circulated through your blood, affecting your whole health, we could say. And that's one of the reasons why we understand air pollution to be so damaging. And again, just to reemphasize what I said before, it's the most important environmental risk factor for health. And we didn't know that before about 10 years ago.
Yeah, I've just got a quick question. So you kind of answered it just now, but picking up on that point about how it does affect the whole body and how in terms of communicating with the public, one of the barriers is that air pollution is still considered, well, it is considered as a risk factor rather than, and it's not recorded, for example, on death certificates, as you mentioned. Can you see how do we overcome that barrier in the public messaging around air pollution?
Yeah, no, wow, that's a great question. And I wish I had a better answer for you, but I'll try to answer. So, right, it's a risk factor. It's something that contributes to people dying, but it's not identified as the thing that causes death in itself. And so the challenge then becomes, you know, in the United States, there's huge awareness of breast cancer. And of course, that's a wonderful thing. There's people who go on, you know, will do a 10-mile walk for breast cancer and raise a lot of money, and it supports research, and that's all wonderful. And it's really heartwarming that people are doing that. But air pollution kills more people globally than breast cancer does. And we need awareness of air pollution as well. And, you know, how do we make those connections more obvious? I'm not sure. You know, one thing I've thought about would be to, you know, if we could name the people that might help, but we can't specifically name any one person. It would be in question whether, you know, it's clear they died of a heart attack, but it would be unclear to what extent air pollution contributed to that. But nonetheless, we would know that some fraction of all the people that died of heart attack, you know, did so prematurely earlier than they otherwise would because they were exposed to air pollution. And it's not just old people. We understand that people in the prime of their lives as well, in some cases, or younger people would die of it as well. I would love to say what the messaging of the story is, but I think we just need to keep making the case that this is as important as other things that we readily accept as very important for health. And the more we say that, hopefully, the more it will come through. We're just lacking those personal stories, and I think that hurts us.
Thank you. So I'm not sure whether we have any more questions before we hand over to our Director of Energy to close the session. I don't see any Q&A or anything in the chat for now. So with that, unless Ismail or anybody else had any further comments to make before we pass the floor to Tarek?
Thank you, Kara. I just would like to thank Professor West for your time. It's really very informative, and it's always good to interact with academia. This is because our work also should have it has to be linked to science, and then that's the starting point. And I really would like to thank you, and we hope that we'll keep in touch for the future, because this is a beginning of a journey. We would like to build up in UNIDO how we can work on air pollution, and not only to celebrate the International Day, which is okay, yes, but action with the developing countries is needed. Thank you very much. And now, Tarek, welcome to our event, and give you the floor.
Thank you, Ismail. It feels wrong to come and give closing words to a session where I missed a substantial part of it due to the engagement and commitment in the and the previous meeting that took over a bit of longer. But I've read a lot about Jason West, and I wanted to really thank you very much for taking the time to enlighten us. And I think it has been a valuable conversation to our to the entire UNIDO community, your participation with us. This has been quite a journey for us yesterday and today to get deeper into the complex aspects of actually air pollution. And the more we dig into it, we realize also what we do is actually quite minimum in terms of what we can impact, but there is a lot of areas in which UNIDO can play a substantive role as an industrial development agency, promoting de-linking industry from pollution on a broad number of issues, and understanding the interaction is extremely valuable for us, and to bring the science into our work is extremely even more important. And so thank you very much for your time, for your contribution. And I want also to thank the entire UNIDO staff community for taking from their valuable time to join in this important milestone and reflection on what we can do. It's a one day in a year, but it's an important reflection to also take individual and collective responsibilities to tackle this. I mean, Jason West highlighted that air pollution kills more people than cancer, and the attention we pay to of course, it is equally important, but also we need to bring a greater awareness of the effect of air pollution on people and health. So with this note, I want to again, on behalf of the Directorate of Environment and Energy, thank everyone that supported this event and this, including our colleagues at the staff union. Thank you very much for hosting the webinar, and to Alfredo and Chiara for organizing the entire process and event. I hope that we can repeat this next year with a deeper dive, and that we can also bring more nuanced interventions in the way we can do our work at UNIDO toward this particular challenge. So with this, let me thank you all and conclude the webinar on behalf of the Directorate. Thank you.